Page 179. We worked with GCF last week, and we will continue just kind of going over a couple of these with GCF. We worked a little bit with GCF. We didn't work extensively, so some of this should be reviewed, but I understand it was on Wednesday, and you had no new assignment, but we just kind of worked through some of these things together. So for 35, 5 and 7, for 54, 6 times 9, 3 and 3, 2 and 3. So 5 times 7, 54 was 2, times 3, times 3, times 3. Now in GCF, when we list out the prime factorization, we try to find out what factors they have in common. If they have something in common, I circle it, I'll write it down. If they have more than one number in common, I'll multiply them against each other. 5, are there any 5s in the 54? No. Are there any 7s in the 54? Therefore, if there is nothing that matches up, you are forced to use what as your GCF? 1. In that case, your GCF would be 1. The greatest factor that they would have in common is just a number 1. (32) and 81. Again, we'll start with the just prime factorization. And I realize that 32 is actually 1, 2, 5 2s. 81 is actually 4 3s. Anything match up there? Therefore, again, our GCF is equal to 1. So sometimes it happens, sometimes it does not. It's just a matter of making sure. Yes. Okay. Sometimes they'll throw variables in there, and this is something that'll be a little bit new. Let's take 18 x y squared and take 28 x squared y squared. Okay? So let's focus first on the numbers themselves. Let's save the variables for last. 18, let's go 3 and 6, 2 and 3. So 18, we've got a 2 and 2 3s. The 28, 4 times 7, 2, 2, 7. Okay. Any questions numerically? How we got the factors, just without the variables? Any question there? From here, we take a look at what we have for variables. How many x's do we have? 1. So let's put, let's do some adjusting. instead of using the x for multiplication, that can get confusing. So let's use the dots. Multiply it times another x. Then how many y's? 2. So essentially, if I break it all down, prime factorization of 18xy squared is 2 times 3 times 3 times x times y times y. They all spread out. Now over here, 2 times 2 times 7, how many x's? How many y's? Okay. From here, we will then circle what they have in common. Numerically, looks like all they have is a 2. How many x's in common? Just the 1. How many y's in common? 1 there, 1 there. So I don't put 2y, I put y squared. So the GCF between those two terms is 2xy squared. Okay. Good. Seven xy to the third and 28 x y to the second. Give it a shot. See if you can. Purposes, we're going to just keep rolling here. So for 7 xy to the cubed, we're going to have 7. I mean, we could put the 1. That's fine. So 1 times 7 times an x times 3 y's. For the 28, that's my 4 times 7, which is going to be 2 times 2 times 7, 1x, and 2 y's. So I do have a 7. I do have 1x. And how many y's do we have? 1, 2. 7xy squared. Okay. So that's what you're looking for with those. I am, like if we just look at 179, look at number 7. Look at number 7, 18C and 4C. Any ideas as to what your GCF would be between the 18C and 4C? Alex? 2C. R and R to the 4th. Chris? Just R. 9, 5m and 20m cubed. Mia? 5m. Good. 3x squared, 15x cubed. Yes. 3x squared. Very good. Okay. So I'm assigning 179 numbers 12 to 19 and 28 to 31. (12 to 19), 28 to 31. Which part? You find the GCF of them numerically, the number-wise, and then from there you just spread everything else out. So if you're looking at 179, so you've got the 18 and the 4. So what they'll have in common with the numbers with 18 and 4 is what for number 7? 2, just 2. And then with the C's, they both have 1 C, right? So they would have the 2 C in common. Okay, Mia. You kind of just take them in parts. Work through the GCF numerically and then work through the GCF with the variables.